Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. So we are starting a new chapter called Binomial Theorem, and you know the importance of this particular chapter from algebra. So in this series of videos, first of all we will explain the concepts of binomial theorem, all subtopics, subtopic wise. In each video we will first explain concept with basic problems, and after completing all the concepts then we will start explaining mains model problems which are important from JEE mains point of view, and then advanced model problems. Okay, fine, let us start. So in this introduction video, in the introduction of binomial theorem chapter, first we will see what is the meaning of binomial theorem, and then some basic expansions like a plus b whole square, a plus b whole cube, etc. And after that we will look at binomial expansion or binomial theorem of positive integral index. So half of the chapter or more than half of the chapter just uses what index, what is the power of the binomial means positive integer. We will look at it, the most important formula in this entire chapter, and then in two different ways how to write the binomial theorem, the binomial expansion using Pascal's triangle and then using combinations. Okay, and next we will see look at some important points to remember after this binomial theorem expansion, followed by some problems in this particular concept. Okay, now let us continue with our video. First let us see what is the meaning of binomial theorem. First, what is the meaning of binomial theorem? So binomial theorem is a rule. It is a rule by which a binomial of some integral index or rational index is written as some series of terms. You know, series of terms means sum of terms, correct or not? So it is the rule by which a binomial raised to power n is written as series of terms, that means sum of terms. This is called binomial expansion, correct or not? So it was actually first introduced by Newton once upon a time. Now if you are already familiar with some basic binomial expansions in your previous classes, maybe from 6th standard or even before that, you know what is a plus b. It is a binomial, it contains two terms. A plus b whole square is a binomial expansion, and all of you know what is a plus b whole square. It is a square plus 2ab plus b square. Similarly, you also know about a minus b whole square, a square minus 2ab plus b square, and then a plus b whole cube. What is a plus b whole cube? A cube plus 3a square b plus 3ab square plus b cube. So you know all these basic binomial expansions that you have learnt already in your previous classes. Now what if you are supposed to remember a plus b whole power 4 or a plus b whole power 5 or a plus b whole power 6 and so on? So we cannot remember or we cannot by heart each and every expansion, correct or not? So we should learn how to write these kind of expansions directly and easily. So where we will learn, obviously binomial theorem will help us, will explain how to write these kind of expansions easily without actually multiplying a plus b into a plus b into a plus b and so on, so many number of times. If you don't know binomial theorem, then to find this expansion you have to multiply a plus b into a plus b into a plus b and so on 6 times. It is very lengthy process. But if you know binomial theorem, it is just in one step you can write the expansion. Now let us see what is binomial theorem of positive integral index, and later we will come back to this to write the expansion of a plus b whole power 4 or a plus b whole power 6 or even a plus b whole power 60. If you know binomial theorem, you can write even a plus b whole power any natural number directly without actually expanding. Okay, let us see what is binomial theorem. Dear students, first let us see how to use Pascal's triangle to write the expansion of binomials. Okay, you might be familiar with Pascal's triangle or you may not. So what is a Pascal's triangle here? For example, you start with 1. Okay, and then keep 1 and 1 in the next row, and in the third row 1 plus 1 is 2, and then you keep 1 and 1 on both sides. And in the next row, in the fourth row, what are we supposed to do? 1 plus 2 is 3, 2 plus 1 is 3, and that's it. Addition is over. You should end this process by keeping 1 and 1 on both sides. And next, in the fifth row, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and you have to end this process by keeping 1 on both sides. And what comes in the next row? Obviously 1 plus 4 is 5, 6 plus 4 is 10, again 6 plus 4 is 10, 4 plus 1 is 5. You have to end this process by keeping 1 on both sides. And let me write one more row. I have written totally 1, 2, 3, 4, 5, 6, and I'll write one more row. 1 plus 5 is 6, then 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 again 15, 5 plus 1 is 6. Let me end this by keeping what on both sides? Again 1 on both sides. Then how can I use this Pascal's triangle to write the binomial expansion? Means what is it? X plus y whole power 0. What is x plus y whole power 0? It is equal to 1. Next, what is x plus y whole power 1 equal to? What is x plus y whole power 1 equal to? See, and then what is x plus y whole square equal to? What is x plus y whole cube equal to? Let us see. In the expansion of x plus y whole power 1, I have written the coefficients already. And next, there are totally two terms. The first term takes x power 1 and the next term takes x power 0. And what about y means? Here we will start with y power 0 and then y power 1. We will keep addition in between them. So you will get x plus y. Of course, x plus y whole power 1 is x plus y. All of us know it. Then what else? Come to x plus y whole square. What is x plus y whole square? Using this Pascal's triangle. So there are totally three terms. The first term takes x power 2, the highest power of x. Next term, x power 1, then x power 0. So the powers of x is decreasing starting from x square. Similarly, the powers of y will be increasing. What is it? First y power 0, next y power 1, and then y power 2. Okay, so then keep plus in between them. So if you write it in simple language, this is equal to x square plus 2xy plus y square. X square plus 2xy plus y square. Similarly, dear students, come to this. What is x plus y whole cube expansion? As I told you, there are totally 4 terms here. Totally 4 terms. So here we will start with highest power of x. The highest power of x in the expansion is x cube. Then we should keep decreasing the powers of x. So in the second term it is x square. Here x power 1 and here x power 0. Next we will start with y power 0 here. Next y power 1, y square, and then y cube. And in between the terms let us keep plus sign. Between the terms we will keep a plus sign. So if you simplify and write this, 1x cube into y naught is simply x cube, and 3x square into y power 1 is simply 3x square y, and this is 3xy square, and this is 1 into y cube is y cube. Therefore the expansion of x plus y whole cube is x cube plus 3x square plus 3xy square plus y cube. Next, what about the expansion of x plus y whole power 4? I think you understood the process. So there are totally how many terms? 1, 2, 3, 4, 5 terms. And the first, from starting, we will take the highest power of x. The highest power of x is x power 4. The next term we will take x cube. The next term we will take x square, and then x power 1, and then x power 0. X power 0 means into 1, not needed to write. Next here y power 0. I am not writing y power 0 because y power 0 is 1, plus here y power 1, here y square, here y cube, and here y power 4, and between the terms we have plus sign. So therefore, dear students, what is the expansion of x plus y whole power 4? It is 1 into x power 4, that is x power 4, plus 4x cube y, plus 6x square y square, plus 4x y cube, plus y power 4. Similarly, you can complete this. Before I write it on the board, so you can try it yourself. Try to write what is the expansion of x plus y whole cube. Pause the video and write this. So and check whether you are correct or not. So it is 1 into x power 5, x power 4, x cube, x square, x and then constant. Then y power 0, y power 1, y square, y cube, y power 4, y power 4. Similarly, you can write this and you can check it yourself. You can check it yourself about the expansion. Okay, now this will be the expansion of x plus y whole power 6. These are the coefficients. And okay, so using Pascal's triangle, observe one thing. Instead of the tedious expansion of x plus y into x plus y into x plus y and so on, Pascal's triangle makes the expansion easier. Correct or not? I can easily find the expansions and I can keep on moving. But there is a disadvantage in Pascal's triangle. What is a disadvantage means? If you want to know what is x plus y whole power 20, obviously you should know what are the coefficients. Correct or not? And if you want the coefficients here, just think once what you are supposed to do. You are supposed to write that Pascal's triangle. How many rows are needed? Totally 21 rows you have to write if you want this expansion. So it's a tedious process again. If you want x plus y whole power 100, then you are supposed to write 101 rows. No one will dare to do all these things. We cannot write 101 rows and we cannot take the coefficients after that. So Pascal's triangle has a limitations. What is it? If the power is a smaller number, I can depend on Pascal's triangle. But if the power is a larger number, it takes lots and lots of time to write the expansion. So therefore, dear students, since Pascal's triangle application has limitations, we will not use Pascal's triangle to write the binomial theorem. Then what, sir, means? Let us use combinations. You know already, you might be familiar with the basics of combinations formulae. Let us see how to write the binomial expansions using combinations. So the most important topic of this entire chapter, the binomial theorem using combinations. Before I can continue directly, I just wanted to revise that NCR formula. So what is NCR? The formula to find NCR value is n factorial by n minus r factorial into r factorial. And all of you must be familiar with factorials. 0 factorial is 1, 1 factorial is 1, 2 factorial is 2 into 1, which is 2. Then 3 factorial is 3 into 2 into 1, which is 6. 4 factorial is 4 into 3 into 2 into 1, which is 24. 5 factorial is 5 into 4 into 3 into 2 into 1, which is 120, and so on. So these are about factorials. In general, n factorial is given by n into n minus 1 into n minus 2 into, and the process will continue. We should keep reducing it until we reach 3 into 2 into 1, where n is a natural number or a positive integer. Okay, so this is some basics about the factorials, and you should revise once again. Okay, now just go through the factorials. Then what is NCR? So for example, and the conditions here, both n comma r must be natural numbers or else positive integers. Okay, now, and this r should always be less than or equal to n, and this r should be greater than or equal to 0, and this r should be a natural number. I'm sorry, r is not a natural number. N, yes, instead of saying natural numbers, let me say that they are whole numbers or non-negative integers. Okay, now I'll write whole numbers. Here also I have to correct myself that n is a whole number, not a natural number, because we also have 0 factorial. Yes, fine. So r is between 0 and n, and r and n are whole numbers, and always remember that r value should be less than n or equal to n. This is very, very important. You should remember. Okay. For example, they told us to find phi c1. So what is phi c1? According to the formula, 5 factorial by 5 minus 1. That means 4 factorial into r factorial, which is 1 factorial. So 5 factorial can be written as 5 into 4 factorial. Please observe. 5 factorial can be written as 5 into, the remaining part is 4 factorial only na, divided by 4 factorial. You will get cancelled, you will get 5. Or else do one thing, 5 factorial is 120 divided by 24, which is equal to 5. It's up to you. Next, for example, 62 is there. 62 according to this formula, 6 factorial by 6 minus 2 is 4 factorial into again 2 factorial. I am just using this formula. So which is equal to, you can write 6 factorial as 6 into 5 into 4 factorial. 6 into 5 into, the remaining numbers are 4 factorial. And in the denominator we have 4 factorial into 2 factorial. So 4 factorials will get cancelled. 2 factorial is 2. So you will get 15. So 6C2 value is 15. Similarly, you can also learn what is 7C3. For example, with the same formula you can check what is 7C3. You will get the answer. Now shortcut. How to write 5C1, 6C2, 7C3, all this without using this formula directly. 5C1, dear students, in the numerator what I should write is, starting from 5, how many numbers should be written in decreasing order means this number will say. So starting from 5, how many numbers must be written in decreasing order means only one number. So 5 divided by this number factorial. So the answer is 5. Again 6C2 in shortcut. How to write 6C2 in shortcut? Starting from 6, how many numbers should be written in decreasing order? 2 numbers. So 6 into 5. Starting from 6, how many numbers must be written in decreasing order? 2 numbers. Divided by 2 factorial. 2 factorial is 2. So 6 5 are 30 by 2, 15. See, very easily we are getting the answer. Again, 7C3. How will you find 7C3 value? Starting from 7, how many numbers must be written in decreasing order? 3 numbers. So 7 into 6 into 5. Divided by what factorial? 3 factorial. You know 3 factorial is 6. So 6 and 6 will get cancelled, you will get 35. So 7C3 value is 35. One last example, 8C4. So how to write 8C4? Starting from 8, I have to write 4 numbers in decreasing order. So 8 into 7 into 6 into 5. I have written 4 numbers in decreasing order divided by 4 factorial. 4 factorial means 4 into 3 into 2. So after 4 2s are 8 and 3 1s are and 3 2s are, you will get 70. So 8C4 value is 70. Okay, so now you understand how to find out the formula of how to find out the value of NCR. Correct? Fine. Few more things before we continue about this NCR. Dear students, this is very, very important. What does it mean? NCR is same as NC n minus R. Is it so? NCR is same as NC n minus R. Let me check. Example, 7C2 according to this formula is same as what? N value is 7 and R value is 2. So 7C2 is same as 7 minus 2. 7 minus 2 is 5. Let me check whether it is true or not using the shortcut. What is 7C2? Starting from 7 I should write 2 numbers in decreasing order divided by 2 factorial. So 7, what is it? 2 1s are 2 3s are, you get 21. So LHS value is 21. What about RHS? Starting from 7 I have to write how many numbers in decreasing order? 5 numbers. 7 into 6 into 5 into 4 into 3 divided by 5 factorial means 5 into 4 into 3 into 2. I forgot that. So 2 1s are 2 3s are. Again the answer is 21. Observe both are same itself, right? Both are same. Both are same, right? Fine. So therefore, what can I conclude? If NCR is equal to NC n minus R, I can conclude that NC naught is equal to what? NC n minus 0. The nc naught means 0. nc0 is equal to nc n. Next, nc1 is equal to nc. Instead of 1 we will write n minus 1. So nc2 is equal to nc n minus 2. And the process will continue and so on. Right? And what is nc0 value? You have to remember this. nc0, starting from n, I should write no numbers. Starting from n, I should write no numbers. Don't get confused. Don't write 0 in the numerator or 0 in the denominator. You write 0 factorial by 0 factorial, you will get 1. Or else ncn. Starting from n, you write all numbers, all n numbers. All n numbers means n factorial divided by n factorial. Both are same, you will get 1. Starting from n, I should write all the n numbers means n factorial divided by this number factorial. Both are same, you will get 1. Similarly, nc1 and ncn minus 1 both are equal to n. And nc2 and ncn minus 2 both are equal to n into n minus 1 by 2 and so on. Okay, these two you should remember. That nc0 is 1, ncn is 1, nc1 is n, ncn minus 1 is also n. Because we will repeatedly use in the problems. How do we use it? In problems, if you find 5c0, no need to calculate 1. If you find 6c0, no need to calculate 1. If you find 100c0, no need to calculate 1. So nc0 is always equal to 1. Similarly, if you find 6c6, no need to calculate, it's 1. If you find 7c7, no need to calculate, the answer is 1. Next, if you find 7c1, no need to calculate, what is the answer according to this formula? The answer is 7. If you find 7c6, what is the answer according to this formula? Again 7. So I will be using these two repeatedly while calculating NCR values. So you have to practice it. Okay, fine. Let us continue with binomial expansion using combinations. Okay, now let us learn binomial expansion using combinations. Okay, so which means I am going to find out what is x plus a whole power n, where x comma a, what are x comma a? They are some real numbers, they can be any real numbers, but the index n is a whole number, non-negative integer. Okay, I will just write whole number. So I am going to write the expansion of x plus a whole power n using combinations. So listen carefully, dear students. First, I'll start with the if power is 0, power is 1, power is 2 and so on. Then by looking at it, let us generalize it. Okay, I'm not going to give you mathematical induction related proof on that. I'm just telling you how to write the expansion of x plus a whole power n using n is equal to 0, n is equal to 1 and that's it. Okay, now let us see first x plus a whole power 0. All of us know that it is 1. This 1 is actually 0c0. If you know the combinations formula, I mean NCR formula, its value is nothing but 1. Okay, next, what about x plus a whole power 1? First, dear students, start writing x powers in decreasing order, then write a powers in increasing order. The highest power of x is x power 1 and after that x power 0. And we will start writing a powers in increasing order. The lowest power of a is a power 0 and then a power 1. Now what about the coefficients? Means look at the index. The index is 1 now. The coefficients are 1c0 and 1c1. The coefficients are 1c0 and 1c1. So add these two terms. There are totally 2 terms. If you simplify it, 1c0 value is 1. 1 into x into 1, which is x, and 1 into a, which is a. Okay, so x plus a whole power n, of course it is x plus a only, but using binomial coefficients. Here you might think it's of no use, but in upcoming expansions, listen carefully. How to write x plus a whole square? First let me write the coefficients. The coefficients are what? It depends on the index. The index is 2, so the coefficients are 2c0, 2c1, 2c2, and we will start with highest power of x. The highest power of x is x square. So x square, x power 1 and x power 0. Next we will start writing the powers of a from increasing order. That means what? A power 0, a power 1, a power 2. Then keep the plus sign in between them. So if you simplify it, what is it? It is equal to 2c0 value is 1, 2c1 value is 2 and 2c2 value is 1. So therefore 1 into x square plus 2 into x into a plus a square. So this is what you get if you simplify it, right? Next, what is x plus a whole cube? Similarly, x plus a whole cube is equal to, first let us write the coefficients. 3c0, next 3c1, then 3c2, yes, and then 3c3. So totally 4 coefficients are possible. Okay, now next we will start writing from highest power of x, that is x cube, x square, x and x power 0. Next, from lowest powers of a, what is it? A power 0, a power 1, a square, a cube, and then plus in between. So the value of 3c0 is 1, 1 into x cube is x cube, this is 3 into x square a. Next, this is also 3 into x a square, and 3c3 value is 1 into a cube is a cube. So x plus a whole cube expansion is this. Okay, so you first write what is x plus a whole power 4 expansion and x plus a whole power 5 expansion, and then check whether you are correct or not from the board. Yes students, x plus a whole power 4 expansion, what is it? First we will write the coefficients. 4c0, 4c1, 4c2, 4c3, 4c4. One student got it out. Sir, why you did not write 4c5? So you should know one thing. This number is always lesser than this number or equal to this number. Okay, now in MCR, R is always less than n or R is equal to n, but R cannot be more than n. Okay, that's why we don't have 4c5, 4c6 and all. Okay, just for you. Now, so after writing the coefficients, first x powers and after that a powers. What is it? X power 4, x cube, x square, x and then constant. A power 0, a power 1, a square, a cube, a power 4, and then keep the plus sign in between them. And then write the values of 4c0, 4c1, 4c2, 4c3 and 4c4. 4c0 is 1, 4c1 is 4, 4c2 is 6, 4c3 is again 4 and 4c4 is 1. So this is the expansion of x plus a whole power. Similarly, you write down what is x plus a whole power 5 expansion, x plus a whole power 6 expansion for your practice. Write down what is x plus a whole power 5 and x plus a whole power 6 for your practice. Okay, now next. Now let me generalize it. X plus a whole power expansion. What is x plus a whole power expansion? Now dear students, what is binomial theorem? If x comma a are real numbers and the index n is a whole number which is non-negative integer, then x plus a whole power n expansion. How to write it? First let us write the coefficients. What is it? The index is n, right? The first coefficient nc0, next nc1. Let me write the binomial coefficients. These coefficients are called binomial coefficients. nc0, nc1, nc2, nc3 and so on. Last one will be nCn. I cannot write every term, correct or not? Next, we will start writing the powers of x in decreasing order. The highest power of x is x power n. So x power n, x power n minus 1, x power n minus 2, x power n minus 3. Okay, and here x power, you will get a doubt, sir, what is the x power there? Of course it is x power 0, correct or not? Next, y powers in increasing order. Y power 0, y power 1, y square, y cube, and what is the last one? It is y power n. y power n, and between the terms we have plus sign. So this is the expansion, dear students. This is the binomial expansion. This is the binomial theorem of what index? Here you have to understand one thing. This is the binomial theorem, binomial expansion of what index? Binomial expansion of positive integral index. That means what? Or non-negative integral index. We can also say non-negative integral index. Of course, we are ignoring power 0. So, binomial expansion of positive integral index. If the power is a positive integer, then this is the formula we use to write the expansion. Okay, very, very important. Sometimes, instead of writing all the terms, since it is a series, sum of the terms, I can use sigma notation. What is it? Instead of writing all the terms, using sigma notation, how can I write x plus a whole power n? X plus a whole power n is equal to summation. Okay, now, first of all, in every term, observe the suffix. The suffix is changing from 0, 1, 2, 3 and so on up to n. The suffix is changing from 0, 1, 2 up to n. The suffix is changing from 0 to n. So, let that suffix is represented by r. R is changing from 0 to n. Next, in every term, in every binomial coefficient, n is n only. Please observe. So, the binomial coefficient is nc. What is the suffix? Who is changing from 0 to n? R is changing. So, it is ncr. And next, look at x power. What is x power? This is very, very important. What is x power means? Here x power is n. Here x power is n minus 1. Here x power is n minus 2. Observe the similarity. X power is this minus this, n minus 1. Here x power is this minus this, n minus 2. And here x power is this minus this, n minus 3. So now you can say what is x power now. So what is x power here? This minus this means x power will be n minus r. And what is a power? A power will be what? Please observe every term and say what is a power. I have to make a small correction. It is not y, it is actually a. Sorry for the mistake. So, what is the power of a everywhere? Here a power is 1, it is the suffix. Here a power is 2, it is the suffix. A power is 3, this is the suffix. And so on, a power is n, which is the suffix. Now, can you guess what is the power of a? Power of a is the suffix here. What is it? A power r. So, therefore, dear students, instead of writing this entire expansion, you can write this using the summation. Sigma r is equal to 0 to n. Next, in binomial expansion, this is called the first term. Okay, now, so this is called the first term, and first term is t1. This is called the second term t2. This is called the third term t3. The fourth term t4, and so on. The last term. You should ask yourself one thing. What is the last term? Is it Tn? Do you think there are n number of terms? Do you think there are n number of terms? Think once. Observe the previous examples. Observe the previous examples. X plus a whole power 1 is x plus a. It had 2 terms. X plus a whole square is x square plus 2ax plus a square. How many terms are there? 3 terms. Similarly, x plus a whole power 3, if you expand it as x cube plus 3ax square plus 3a square x plus a cube, it had 4 terms. Dear students, if index is 1, the number of terms is 2. If index is 2, the number of terms is 3. If index is 3, the number of terms is 4. So you can say how many number of terms are there? How many number of terms are there in this given expansion? So the given expansion contains in x plus a whole power n, how many number of terms are there? Number of terms is equal to n plus 1. It is not n. If the index is n, then the number of terms is n plus 1. Therefore, if the first term is represented by t1, the second term as t2, the third term as t3 and so on. In the last term is what? Tn plus 1. Please understand this. There are totally n plus 1 number of terms are there. The first one is t1 and the last one is tn plus 1. Okay, next t1, t3, t5 and so on. These are the terms in odd place. t2, t4, t6 etc. are the terms in even place. Okay, now fine. Now what is general term in this expansion? Let us see what is general term. And very important, general term of x plus a whole power n. So what is general term? Students will make a small mistake. They will write the general term as TR, but it is not actually TR, it is TR plus 1. How to write the general term? Observe this. If it is fourth term, it is NC3. If it is fourth term, it is NC3. Correct or not? So remember, fourth term is nothing but 3 plus 1th term. Correct or not? So if it is fourth term, what is the suffix? Suffix is this number. Correct or not? So, and then x power, how to write, a power, how to write, you know very well. Correct or not? So therefore, in general term, what is the suffix here? NC. What I should write here? I should write this. NCR. X power, you know, n minus r, and a power is the suffix r. This is the general term. So what is the use of general term? Because in problems they will ask us to find the 7th term, 8th term, 10th term. Then no need to write the entire expansion. Use the general term and find the 7th term. For example, in this question, they are asking us to find the 10th term. So what term they are asking? 10th term, T10. T10 is nothing but T suffix 9 plus 1. So what is the R value? R value is 9. So what is the 10th term in this expansion? NC9, x power n minus 9, a power 9. Please observe one thing. If they are asking 10th term and here we got the suffix as 9. What mistakes generally children will do is that if they are asking 10th term, they will write 10 here. Be careful. It is not 10, it is 9. Okay, now according to formula we should write this. For example, they are asking us to find the 97th term. Then what we should write? 97th term means T 96 plus 1. So R value is 96 and it is equal to what? NCR. R means 96. X power n minus 96 into a power 96. You can write like this. Right? So here is the general term. So we will see how to use general term again in problems. Okay. Now let us discuss some important points that we have to observe in binomial expansion. Some important points to remember, dear students. The first point is that if the index is n, the number of terms is n plus 1. So number of terms in the expansion x plus a whole power n is n plus 1. So if it is x plus a whole power 100, it contains 101 terms. If it is x plus a whole power 999, then it contains 1000 terms. So first thing is number of terms. Next, second thing is what you have to, what is it? You have to observe. In every term, what is the power of x? Power of x is the difference between these two. Correct or not? Here the power of x is n minus 1 and here the power of x is n minus 3. Okay, now so that is second point. Okay, next, what is the third point? What is the third point? Means power of a. So what is the power of a here? Power of a is the suffix r value. So here a power is 1. Here the power of a is the suffix 2. Here the power of a is the suffix 3 and so on. That is the third point. Next, what is fourth point? So fourth point is our general term. TR plus 1 is equal to NCR into x power n minus r into a power r. So that is the fourth point. Next, fifth point. Fifth point, dear students. Next point you have to remember is, for example, if you take this term, what is the coefficient of x power? Coefficient of x power n minus 3. Obviously, a is a constant, x is a variable, a is a constant. So coefficient of x power n minus 3 is NC3 into a power 3. So similarly, in our general term, NCr into x power n minus r into a power r, what is the coefficient of x power n minus r? The coefficient of x power n minus r is NCr into a power r. So the coefficient of x power n minus r is NCr into a power r. Remember this. Next point, sixth point, the common mistake what students do. If the question is like find the sixth term in expansion x plus a whole power 11, they will ask us to find the sixth term in x plus a whole power 11. And what some of the students will do is, they will find the sixth term in a plus x whole power 11. And they will say that, sir, these two are same only na, x plus a whole power 11 is same as a plus x whole power 11. So sixth term in this expansion will be same as sixth term in this expansion, right? That is what they think, but that is not correct. The sixth term in the expansion x plus a whole power 11 is not same as the sixth term in expansion of a plus x whole power 11. If you want, you can check what is the sixth term in this expansion according to T6, that means T5 plus 1. In this expansion, the sixth term is NC5 x power n minus 5 into a power 5. And the sixth term in this expansion is actually NC5 a power n minus 5 into x power 5. Here it is a power 5 and here it is a power n minus 5. Both are not same, correct or not? Here it is x power n minus 5 and here it is x power 5. They are not same. These two are not equal. So understand one thing, dear students. In general, the pth term in this expansion, what is it? The pth term in expansion x plus a whole power n is not same as the pth term in the expansion a plus x whole power. Remember this, very very important. Okay, next. Some of the models will be like, find the 10th term from the end, find the 11th term from the end, find the 12th term from the end. In the expansion they will ask like this, correct or not? So what is it, dear students? There is a formula like this. The kth term from the beginning is same as n minus k plus 2th term from the end. Or else you can also say the reverse, kth term from the end is same as n minus k plus 2th term from the beginning. You can interchange those words. So how to prove this? It's very simple. See, total how many number of terms are there? Which expansion? Of course, in the expansion of x plus a whole power n. So the expansion is x plus a whole power n. Total how many number of terms are there? N plus 1 terms are there. What are the n plus 1 terms? T1, T2, T3 and so on. Somewhere we have kth term. Kth term is what? Tk, Tk plus 1, Tk plus 2 and so on. Total number of terms are n plus 1, correct or not? Tn, Tn plus 1. Total from starting from first term to n plus 1th term, there are totally how many number of terms? N plus 1 number of terms. Let us locate the kth term from the beginning. This is the kth term from the beginning. If I start counting from the starting, first term, second term, third term, like that, it is kth term. But if I start counting from the ending, first term, second term, third term, like that, then what is the number of this? So according to the question, what is the number? The number here is n minus k plus 2. It is n minus k plus 2 term from the end. But how do we know that? Very simple. Just observe one thing. I want the number of this term, correct or not? I want the number of this term. So what I will do is, from the total n plus 1 terms, I will remove all the terms before it. So what is the term before it? Tk minus 1. Correct or not? From total number of terms, if I remove all the terms before the kth term, then how many number of terms are remaining? From total n plus 1 number of terms, I have removed how many number of terms? K minus 1 number of terms. How many number of terms are removed? K minus number of terms are removed. Then how many number of terms are remaining? N minus k plus 1 minus into minus plus 1 you will get. So how many number of terms are remaining, dear students? N minus k plus 2 terms are remaining. Correct or not? In this is the first term, this is the second term, and before it is the third term, and this is which term? N minus k plus 2th term. So therefore, dear students, kth term from the beginning is equal to n minus k plus 2th term from the end. So once again, if you want to understand this, what is it? There are totally n plus 1 terms are there. I want to know this is which term from the end. So what I did, from total n plus 1 terms, I have removed all the terms before the kth term. All the terms before the kth term means how many terms are removed? K minus 1 terms are removed. Then how many number of terms are remaining? These many number of terms are remaining. N minus k plus 2 terms are remaining. Out of these number of terms, this is first term, second term, third term, and so on. What is its number? N minus k plus 2. Okay, na? So that's why kth term from the beginning is equal to n minus k plus 2th term from the end, or else kth term from the end is equal to n minus k plus 2th term from the beginning. Okay. So if you want to understand this with a simple example, let me consider x plus a whole power 36. X plus a whole power 36. 17th term or 17th term from the beginning is equal to 17th term from the beginning is equal to which term from the end? 17th term from the beginning is equal to which term from the end? Which term from the end? So total how many number of terms are there? If the index is 36, then totally there are 37 terms. Please observe, don't write 36 terms. If index is 36, how many number of terms are there? 37 terms are there. Somewhere in between you will have 17th term. Okay now? So it is 17th term but from the beginning, and I want to know its number from the end. If this is first term, second term, if I count like this, what is its number? Okay now? So to know its number, what I will do, from the total 37 terms, I will remove all the terms before the 17th term. So how many terms are there before the 17th term? 16 terms are there. I have removed that 16 terms. From 37 terms, if I remove these 16 terms, how many are remaining? 21 terms are remaining. So what is the number? So what is the number of this from the end? If I count it from the end, it is which term? 21st term. So dear students, 17th term from the beginning is equal to 21st term from the end. Okay now, then you can calculate, you can use this concept while solving the problems, right? And one last one point, dear students, LHS in this expansion, x plus a whole power n, is always equal to RHS. LHS is always equal to RHS for every value of x and a. In place of x and a, you can substitute any real number or any complex number. LHS is always equal to RHS. Correct or not? And for this reason, since for every value of x and a, LHS is equal to RHS, this binomial expansion is an identity. Already you have learned that a plus b whole square is an identity. A plus b whole cube is an identity. Why we call them as identities? Because LHS is always equal to RHS for every value of x and a. For this reason, this is an identity. Okay now? So remember this. And dear students, this NC0, NC1, NC2, NC3, all these are called binomial coefficients. So we will discuss more about binomial coefficients in upcoming videos. So now, based on the concept what I have discussed, let us discuss some basic problems. Here is our first basic question. Expand 3p by 4 minus 4q by 5 whole power 4. Okay, it can be plus or it can be minus, it doesn't matter. So what is this expansion? Let us see. The expansion of 3p by 4 minus 4q by 5 whole power 4 using binomial expansions. First of all, let me write the binomial coefficients. 4c0, 4c1, 4c2, and then 4c3, and finally 4C4. It contains totally 5 terms, right? Now here we will get what? 3p by 4. We will write the powers of 3p by 4 in decreasing order, which means 3p by 4 whole power 4. Next 3p by 4 whole cube, 3p by 4 whole square, 3p by 4 power 1, and then 3p by 4 power 0. That is not needed. Next step, we will write the powers of minus 4q by 5 in increasing order. So here minus 4q by 5 power 0. Power 0 means 1. Next step, into minus 4q by 5 whole power 1, minus 4q by 5 whole square, minus 4q by 5 whole cube, and finally minus 4q by 5 whole power 4. Okay. Now, if you simplify it, you will get your answer. 4C0 value is 1. 1 into 3 power 4 is 81 into p power 4 by 4 power 4 is 256. I am supposed to keep the signs in between the terms, the plus sign. Next, let us decide the sign first. Minus power 1 is minus. Minus into plus is minus. 4C1 value is 4. 3 cube is 27. P cube divided by 4 cube is 64 into minus I have already taken out, you get 4 cube by 5 plus 4C2 value. In shortcut I told you how to find 4C2 value. 4 into 3 divided by 2, which is 6 into 3 square is 9, p square by 4 square is 16 into minus square is plus. That's why I have kept plus sign here. Into 16. 4 square is 16. Q square divided by 5 square is 25. Next, plus 4C3 value is 4 into, so 3p by 4 as it is. I have to tell you one thing. Let us decide the sign first. Minus cube is minus, so minus into plus will be minus. You will get minus sign here. So 3p by 4 into 4 cube will be 64 into q cube divided by 5 cube is 125, and then minus power 4 is plus, 4C4 is 1, 4 power 4 is 256 into q power 4 whole divided by 5 power 4 will be 625. 5 power 4 will be 625. I think that particular term is not visible, so let me write that here. So plus 1 into 4 power 4 is 256 into q power 4 divided by 625. So you can write the next step by simplifying. 4 1s are 4 16s are, and 4 1s are 4 4s are. Then 2 3s are, 2 8s are, 8 1s are, 8 2s are. 4 and 4 will get cancelled, and then here no cancellations. What is our final answer? So our final answer will be 81 p power 4 by 256 minus 27 p cube divided by 4 5s are 20, and we also have q here. Next, plus 3 9s are 27, 27 2s are 54, 54 divided by 25 into p square q square, and after it minus 64 3s are, 3 4s are 12, 6 3s are 18, 192. 192 divided by 125 into p cube, p into q cube, plus 256 q power 4 by 625. So this is the expansion of the given question. So this is equal to this. Okay, this expansion might be lengthy, but generally we will find a simple expansions like 3p minus 4q whole power 4 like that. Okay, this is the first model, expand. They will give a binomial and they will ask us to expand. So directly we will use binomial theorem and we will expand it. I hope you got clarity in this particular model. You try to solve 2 or 3 more models from this. Okay, now under this expansion. Okay, we will find these expansions in many of the questions, in upcoming questions. Next, what is next model? Here is a simple question. Find the 6th term in this expansion, or 16th term, or 20th term, whatever it is, how to find one particular term in this expansion which contains 21 terms. In the expansion which contains 21 terms, how to find the sixth term? Using the general term formula. So what is it? We know that TR plus 1 is equal to NCR into x power n minus r into a power r. And you are supposed to find the sixth term. Sixth term is nothing but T5 plus 1. So therefore T5 plus 1, where r value is 5. What is it, dear students? N value is 20. So NCR means 20C5. X is the first term, so 5x by 3 whole power. All of you know what is the power of the first one. It is 20 minus 5 into, what is the second term? Y by 2 whole power, the suffix 5. So 20C5, no one will expect us to calculate. Okay, now you can keep it as 20C5 itself into 5 power 15. Okay, divided by 3 power 15. Okay, into 1 divided by 2 power 5. Okay, into x power 15 into y power 5. So they will not expect us to simplify it. If you want, you can write 2 power 5 as 32, but it's okay. Or sometimes the same answer will be in different form. So depending on the options, you can choose it. So this is the sixth term. Therefore the sixth term is 20C5 into this number into that. So here is the sixth term. Here is a question. They told us to find the 16th term from the end. They are not asking 16th term from the beginning. They are actually asking us to find 16th term from the end. 16th term from the end. What is it? Once again, as I explained before in the concept, there are totally how many number of terms, dear students? The index is 39. So therefore the number of terms is 40. So what are the terms? First term, second term, third term, and so on. Somewhere we have, okay, and so on, we have totally 40 terms. Total there are 40 terms. 16th term from the end. Okay, now I want the 16th term from the end. What is it? 16th term from the end means. So I want 16th term from the end. Okay, there are totally here 16 terms. And then here how many number of terms are there? 24 terms. Correct or not? Because total 40 terms are there. From here 16 terms are there means the remaining are 24 terms. Remove these 24 terms, or yes, what is it? The 16th term from the end is same as what? 24 terms plus one extra term. After 24 terms only you are getting this term. Correct or not? So it is which term actually? 25th term. I hope you understood this. What is it? Total 40 terms are there. I want 16th term from the end. So let me take the 16 terms from the end. Then how many remaining number of terms are there? 24 terms. And this 16th term is what? 24 terms from the starting plus 1. Correct or not? Therefore 16th term from the end is equal to 25th term from the beginning. 16th term from the end is same as 25th term from the beginning. Or else you can use that formula. What is that formula? N minus p plus 2th term. So what is it? N here? N is not 40, N is 39. 39 minus p is what? Which term you want? 16 plus 2. What is it? 39 minus 16 plus 2? Again 25 only, it is the 25th term from the beginning. So find the 25th term. So 25th term is equal to t 24 plus 1, where the r value is 24. So what is the formula first? Let us write the formula. I will write it here. T25 is T24 plus 1, which is, first let me write formula. NCR into x power n minus r into a power r. N is the index, which is 39. 39C, the suffix r is 24. Into x is the first term, 3y. 3y power 39 minus 24, which is 15, into a is what here? A is minus 4z. 4z power minus 4z power 24. So this is the 16th term from the end. Sometimes in answers minus power 24 will be taken as plus. Okay now, and sometimes in answers instead of 39C 24, what you will find? Instead of 39c 24, you will find 39c 39 minus 24. 39 minus 24 means what? 15. Remember this, dear students. Sometimes in options, instead of 39c 24, you will find this, particularly in more than one correct type of answers. Okay, so these are the three basic models which comes from the topic which I have explained today. Yes, today we have discussed about binomial theorem, binomial expansion using Pascal's triangle, and after that combinations. Okay, in this entire chapter I will write binomial expansion using combinations only. Okay, now so we have discussed about general term after that, and next we have discussed some important points. What are the important observations we have seen from binomial expansion, and then we have discussed three problems. Okay, so in the next video we will discuss some standard expansions, like what is x plus a whole power n plus x minus a whole power n, x plus a whole power n minus x minus a whole power n, then what is 1 plus x whole power n, 1 minus x whole power n. All these things we will discuss in the next video. So thank you, dear students. I hope you understood this concept. So in case if you understood this, and if you feel that it is useful for your friends also, do share this video with your friends. Comment your feedbacks in the comment section, and if you are new to the channel, do subscribe it. So we'll continue in the next video. This is M. Sandeep Kumar. See you all later.